Welcome to the video lecture on quantum computing. So today we'll discuss what is the importance of quantum computing and why we are going for quantum computers. So what is quantum computing? Quantum computing is an area of study focused on developing computer technology based on quantum principles, the basic physics theory which explains the nature and behavior of energy and matter called quantum in atomic and subatomic levels. A quantum computer is a computation device that makes direct use of quantum mechanical phenomena such as superposition, entanglement, and to perform the operations on data. So why we require quantum computing? Quantum computing. So in nowadays, the normal computers has reached its limits by the size as well as the number of transistors that they can fit in a chip. So maxing out the number of transistors per chip, reaching the minimum size of the transistors and reaching the limits on the speeds of the devices. So eventually, so the researchers are focusing on alternative solutions. So we find the some alternative solutions are DNA and cellular automation and quantum techniques. So DNA is a biological method where you use biological neurons to store the data, and cellular automation, it uses automation to do the operations on data. Again, quantum computing uses physics to get the quantum physics to store and analyze and do operations on the quantums. So basic concepts of quantum computers and the differences with existing in computers. So in existing computers, as all of you know, it is a binary one, so which operates on zeros and ones. So binary. So when entity it's and the entity that requires the information is called as a bit, which is called as binary digit. Either it may be 0 or 1. A bit can be either 0 or 1 at any instant, one instant of time. But on the other hand, on quantum computer, it uses a quantum bit or qubit instead of a bit. So a qubit also makes use of two states, 0 and 1, to hold information. But in contrast to a bit, in this state, a qubit can take on the properties of zeros and ones simultaneously at any one moment. According to the qubits, two qubits in a state can express four values: 0, 0, 0, 1, 1, 0, and 1, 1 at one all at one time. So this is the classic definition of a bit and a qubit. So the classic bits, if you observe here, the black one and white one. So black represents 1 and white represents 0. So either it may be 0 or 1. So either 0 or 1. So 2 power n combination. So 1 out of 2 power n combinations you'll get. But in a qubit, so it can be either 0 or 1. Either it may be both 0 and 1. So such that all the number of possible combinations will be permutations will be 2 power n. So therefore, a qubit has more speed when compared to the normal bits. So classical qubits are differences between classical. So if you observe here, the diagram shows the classical bit and a qubit. So classical bit, either it may be 0 or 1. Any two states it can be available. But a qubit can be 0, 1, superimposed or superposed states of 0 and 1. So then the diagram shows the difference between the classical bit and a qubit. So what is the difference between the quantum computers? There is a much difference between quantum computers and classical computers, but here we'll explain only few terminologies related to the quantum. One is quantum supercomputing, quantum entanglement, quantum teleportation. So quantum, what are the quantum principles? So superposition, whatever we have discussed in the earlier side. So quantum superposition, entanglement, and interference. So if you observe here, these are the diagrams which explain quantum entanglement. So if you observe here, if two states are entangled to each other, such that if you keep a distance, so one side of the earth to the other side, if you change one, automatically the other also changes without any connection between those two. So this is called as entanglement. And so qubit here inferences, qubit is a quantum wave functions which is converted into overall wave functions, and there we consider the probability. So interference, so amplifies the correct outputness. So quantum superposition. Superposition is a word from a old concept that has two things can overlap on each other without interfering each other. In classical computers, electron cannot occupy the same space at the same time, but a wave can be at same time in two spaces. So one may think of this as a vector and the probabilities drawn in two-dimensional coordinate system and a complex plane, that is coordinates the form x plus iy. X is a real number or y is an imaginary number. Classical bits are either 0 or 1 and they don't have any imaginary part. So if you observe here in a qubit, so 1 and 0. So real axis if you assume as a real and 1 as imaginary. So the this wave can exist in between 0 and 1 at any vector representation. Next, quantum entanglement. Entanglement is an ability of quantum systems that exhibit correlation between the states and within a superposition. So quantum entanglement is one central particle of quantum physics that is highly misunderstood. So quantum entanglement means multiple particles are linked together. And if you separate those particles, so from one end of the universe to other end, if one changes its states, automatically the other also changes its states. So if you observe here, this is the example for a quantum. So qubit, if you observe here, once this two bits are entangled, so for after if you separate these two for at the ends of the universe also, you will get one. If you change the position of one bit, automatically the other will change. That is called as quantum entanglement. Next, quantum teleportation. Quantum teleportation is a technique that transfer information from quantum level, usually from one particle to another particle. Next, quantum computer language. So, what are the languages? So, like in normal computers, we use C, C++, Java, Python, like that. So, in quantum computers, we have different languages. That is QCL and then QGCL and then quantum C. These are the currently used languages to write program inside a quantum computer. So, what are the applications of this quantum computer? So, quantum computer can be used in cryptography, modeling and indexing very large databases. It can be used to solve complex mathematical problems, military searches of quantum computers, Google image search, teleportation, improved error and data connection. So if you observe here, and nowadays data scientists and analysis of data is increasingly rapidly increasing its importance. So at the time, normal computer takes a lot more time to process those large database, so like LLMs, those are used. So where normal computers use more time to solve this, whereas this quantum computer will use less time with more efficient. And if used in cryptography, so this can use an added advantage that so decryption of this is very complex and it should be very. So and it can be used as solving mathematical problems such as complex problems. Right now, most of the scientists are focusing on more mathematical problems, which you require quantum computers for each and supercomputers for each and every problem. So instead of using supercomputers, we can use those calculations in normal quantum computers. So what are the advantages? So it can process more amount of data and the errors are less, and it can give more accurate results with much faster speed. So they are used to protect web pages, encrypted emails, and many other data types. So what are the recent advancements that you can see in quantum computing? So IBM Quantum 2, it has released in December 2023, is designed for scalability and houses three Heron processors, and it can be expected to up to 4158 qubits of data. And the second one is Mojaro by Microsoft, and DWFI European expansion. So in Maharashtra Quantum Corridor also using quantum AI with IONVOQ SCA and Scandian AB to establish a quantum corridor in its state. So this is a quantum photonics. So this is photonics. Researchers are developing optical chips to integrate with photonics like waveguides and detectors to manipulate on single photon. So these are the recent advances that are happening in quantum computing. So thank you.